Hi, good day everybody. I hope you're doing great. And my name is Ruslinda. I'm from University Malaysia Perlis, from Institute of Nanoelectronic Engineering. Well, my major is actually Electrical and Electronic Engineering, my degree. And my master's I'm doing on nanoelectronics, my PhD in Biosensor. So I have three different sort of measuring fields that I work with. And the question is, when I did my PhD, is like to emerge the electronics with the biologicals to become one of the biosensor things that what we could help the humans and what we could benefit the country, especially for Malaysians. But before I go further with my topics, I would like to introduce you the University of Malaysia Perlis by showing you a corporate video from our university. This is our scenery as a part of Northern Malaysians. In Malaysia, we are the neighbor country from Thailand. So in our university,
this is where engineering, technology,
our
and
Vice Chancellor,
studies
Dr. Zul Azhar
beneficial to the
Jamal.
future begin.
His background is actually physics.
The ministry approved the establishment of College University Kejuruteraan Utara Malaysia, Hukum, the 17th public university.
We were established in 2002 as a college university, and in 2007 we have been nominated as a university.
UNIMAP offers programs of study leading to the award of diploma, bachelor's, master's and PhD degrees. UNIMAP operates in three main campuses: Nature Campus Putra, Computer and Communication Engineering, Manufacturing Engineering, Electrical System Engineering. Microelectronic Engineering, Mechatronic Engineering. Unicity Nature Campus, Faculty of Engineering Technology, School of Diploma Studies, City Campus, Materials Engineering, Bioprocess Engineering, Environmental Engineering, Business Innovation and Technopreneurship, Human Development and Techno-Communication. UNIMAP continuously carries out research that brings benefit to all. Nanotechnology research in UNIMAP looks into faster, easier, and more accurate detection of microbiological diseases. The HPV-CC kit has high sensitivity that allows early detection of cervical cancer through saliva. With the application of greenhouse technology, the Sustainable Agro Technology Institute has developed a method to enable the Perlis harum manis to be harvested all year long. A greenhouse monitoring system has been built to regulate temperature, humidity, and level of carbon dioxide to create an environment conducive for the growth and maturity of the fruits. A bus monitoring system developed by the UNIMAP Center of Excellence for Advanced Sensor Technology facilitate efficient monitoring of the movement of university buses for students. Under UNIMAP's social responsibility programs, an alternative energy source kit known as EPS kit has been developed. Each year, UNIMAP produces alumni whose presence is felt the world over, in many parts of the world.
Even though it's a different industry, different profession, but we still need the soft skill, the leadership skill that we learned, that we were taught in school during our university days. It's a lesson learned. We were taught as we through this life.
Being graduate from UNIMAP, it really helps me in adapting to the working environment, and it helps me speeding up my learning curve. And I think the best thing about UNIMAP is they don't just teach you, they prepare you.
The soft skills, problem-solving analysis, as well as a lot of hands-on practical that we practice. It will help the graduates to be more confident when they graduated later on.
The levers in UNIMAP actually helped me a lot for this business. So here I want to thank UNIMAP for giving me a very good education for me. UNIMAP mantap.
UNIMAP researchers are globally recognized, evident through the acquisition of numerous international grants.
UNIMAP is my first choice because the programs offered here are focused and they fulfill the expectation of the industry.
Apart from academic and research, which are the university core business, sport, culture and volunteerism are also given due to the attention. It's up to the student to choose which field he or she want to immerse into.
The success and achievements thus far have placed UNIMAP on the world stage.
We hope the people we guide and shape here are competent enough to live lives that benefit themselves, their families, their countries, and the world at large. Our journey is still long, but with knowledge, sincerity, and excellence underlying our conviction, I believe we can succeed, inshallah. UNIMAP Mantap.
Okay, that's it about the University Malaysia Perlis. What we have seen is the corporate video. We are actually a focused university that only focuses on engineering, but you have seen that some of the business and the technology of the communication, the human development was two schools that came with a new idea of our engineering courses. Now, how many of you have heard about Malaysia? And does any one of you have been to Malaysia? I think some of you have been, but some of you may not. And in fact, Malaysian, some people like, Malaysia, where is it? So let me introduce you a little bit. Where is Malaysia? And okay, this is I will skip this for a while. So let's have a look on the Malaysia at a glance. The population is about 31 million, and we have three different races: Malay, Chinese, and Indian. And even we are multi-ethnic country. And as you may see, we have the Peninsula Island here and the Borneo Islands. So this Borneo Islands, it's more on the multi-ethnic culture. So we have several cultures and we have several races, but the major races is Malay, Chinese, and Indian. And we are nearby with the Singapore. That is where we are, Malaysians. We are not a very big country, but it's small. Our country is a tropical country. We doesn't have snow, we doesn't have autumn. It's always summer. And in fact, we do have a raining seasons quite sometimes. So, University of Malaysia Perlis is actually here, over here. Okay, it's nearby Thailand. So we are the nearest part with the Thailand. And we can enter Thailand is about half a minute, 30 minutes, half an hour, you can enter the Thailand. That is the border between our university and the Thailand. So the beautiful of Malaysia is like, we have so many fascinating things in Malaysia, like we have a Petronas Twin Towers, and we also have like Mount of Kinabalu in the Borneo that you can go for hiking. We have plenty of islands that you can go for island hopping and diving with the beautiful corals. And we have a tropical fruits. And have you ever heard about durian, the king of the fruits? That is actually from Malaysia as well, which is these are the durian that some people who not really can't be smell of it, but some people love the smell of durian. It depends how you take it actually. So these are the tropical fruits that we have, such as a rambutan is like a comb fruits, and also we also have a mango. And the specialty of our regions, our northern regions for the mango is like, they call it harum manis, which is the smell and the sweet. Okay, the reason why, as our regions, the Perlis is the northern part, the weather is slightly dry and slightly hot as compared to the Kuala Lumpur. So this mango, the harum manis mango, is actually have a seasons between April and May. So normally, visitor will come during that period to taste the difference of the normal mango with the harum manis mango. That's the beauty of the university, the Perlis region, that we are looking forward making that mango is harvested through a monthly throughout the year. On the other hand, some people claim that Malaysian is the food of heavens because we have so many multi-races. So we have Indian food, we have Chinese food, we have Malay foods, and we also have a different kind of ethnic, like a very unique dessert or very unique dishes that have in Malaysia. So if you have times and if you would like to come to Malaysia, I really welcome you to see what are the fascinating things, because there's a numbers of millions of things that I could share with you, but due of time, I just pick up the most famous foods in Malaysia. Like we have a roti canai, that these are from Indian food. The nasi lemak is actually from a coconut milk with the spice and the eggs. And then we have a lot assorted of desserts with the sweet things. And we do love sweet things. And all of this kind of dessert is very, very sweet. I'm sure some of you have been to Malaysia and tasted it, but it's delicious. You definitely have to come one day in Malaysia and try to taste it and see and look what you have experienced on it. I think that's all about Malaysians. Now, let me show you on what are the topics that I'm giving to talk today as the evolutions of biosensor, the challenging in solving a global health issue. So let's get back to the main. All right. So this is the outline actually that I would like to share with all of you. What is a biosensor and what's the demand in the market for the biosensor and the advancements of the nanotechnology, the specific towards the nanomaterials, the nanostructures, and of course the evolutions of biosensor to solving the current global health and what we have may seen and what are the challenges that appears toward us. And also some cases on the past, present and futures towards the cardiovascular, which is heart attack disease, and the lastly is a summary. So I'm not really sure whether you have heard about the biosensor, but biosensor is actually, is a analytical devices, and it could be combined with a high sensitive and selective with a biological molecule, with a certain physical transducer that converting a biological into a readable signal measure. So what we have here, you could see here that we have the analyte is a biological molecule. We have a receptor here. It could be DNA, it could be antibody, it could be a small molecule or even cell in a bioreceptor. And this is what we call it a transducer that converting the biochemical signal into the interactions from analytes and bioreceptor. And lastly, they will convert it into electrical signal. This is what the biosensor means. Now, looking at this, when we have a bioreceptor, it could be DNA, it could be a cell, it could be antibody. So what are these transducer, the recognition element do? So how do we attach the receptor towards our transducer, towards our sample? So to make it as effective a biosensor, these 5 issues need to be aware and need to be improved, optimized. So first is the immobilization techniques, which how do we make the DNA to be attached with the transducer becoming stable and not to be removed away. And the other part is the compatible electrode. When we have a transducer, we have to make sure the sample is very compatible with the biomolecule when we add the biomolecule towards the transducer. On the other hand, like this one is a cell, the stability. How does this 4 biorecognition element stable? How does it going to be stable? Is it the way we use the reusability of the biosensor, or is it how we make it become strongly attached with the transducer? That is a part of the issues in the biosensor. And also the test conditions. Test conditions we referring on the pH, the temperature, and lastly the electrode transfer mechanism. When we decide a bioreceptor, we need to identify how does it sense, how does the mechanism work. If we choose, for example, for DNA, so what is our applications towards that? And how are we going to make the DNA that converting into some signal that we could understand the mechanism, the interactions. So these are the issue that when we choose a bioreceptor or recognition element that we have to take into account. On the other hand, the transducer. The transducer can be electrochemical, it can be in the several types of measurements. For example, here I show you, it could be in amperometric, that measuring a current resulting from oxidations, reductions of electroactive or biological elements. It could be potentiometric, where it's measuring the potential difference between the voltage and the working electrodes. And it could also be a conductor metric that contains 2 elements, sensitive conducting layer and contact electrodes. And there are several other techniques that we could put into transducer. This is on device of the electrochemical. How about the field effect transistor? It could be one of these as a transducer, that field effect transistor converting the current and voltages as well. And of course, the imaging from the color changings, like red to purple, purple to pink, that what already have in the market, like a pregnancy test, like a HIV disease detections, to see the color difference. Those kind of things is actually, we call it as a biosensor. But the mechanism, the detections is different. So, what are the drivers when we say as a biosensor? And when we want to create a biodiagnostic, what we need, the performance of that sensor is first the sensitivity. Okay, the sensitivity of the biosensor, whether is it when we have in a lower concentration, that the device could be detected, or it have a certain limitations of the concentrations. On the other hand, the selectivity and the versatility of the biosensor. When we have, look at this as an example, we have, normally when people have the cancer, they go for biopsy. And some, they took an ELISA and they took a sample of blood. But in looking in the future, we are looking for the non-invasive methods. Okay? That's why people are now moving towards like urine, like saliva, like a sweat. But to make this a biosensor become a reality, we need to be able to have this sensitivity, selectivity, and of course, the robustness and the portability of the biodiagnosis. These are the drivers when we are developing a biosensor. So, why we need a portability then? Because we have to understand now some people are quite fear to go to the hospital to check their medical checkup. So they are rather to do like home inspection alone and then goes to the hospital. And in fact, for the HIV patients, okay, some of the drug addicts, they are really ashamed to go to the hospitals. So they might doing testing at home. So that's why we need a portable device that they might not need to have high skill and they can operate in a simple way to identify their disease. Okay, these are the drivers. Now, look at this market in the glucose biosensor. Okay, yes. How do I can detect the HIV? Without Okay, thank you for your question. The technology. To answer your questions is that the virus is nowadays, we are normally taking from the blood, right? I mean, in current now. But now we have a saliva technique, okay? We use a saliva. So when we wake up early in the morning, there has been commercialized in Malaysia using the saliva that we take it's like a cotton bud. You take your saliva, you put in a wafer, and you drop in like a slip, like a strip, okay? And then it will show you a color. Another sample is, you use your saliva also, but it will looking at the quantitative of the protein that presents in the HIV virus. Am I answering your questions? Okay. So, looking at this, the global biosensor market, I would like to highlight this, the point of care device, the point of care, okay? The demanding of the point of care has been increasingly from starting in 2012 and 2020. But again, it might be increasing in 2025. But why does the point of care is really needed and why people are demanding on that? That's the questions, okay? And looking at that, the food industry has becoming a slightly gap, food industry, and also the home healthcare. So what is point of care? Okay, the point of care is actually a medical diagnostic that performed outside the clinical laboratory in close proximity where the patient is receiving care. That is what people are looking at, point of care testing device. And the advantages is that we are using a non-invasive, okay? It can be detected in the sensitive detections at low cost and easy to use with a rapid analysis. If you look at here, there shows some example of point of care, but most people are using like pregnancy tests, and even now we have a diabetics, okay, to see the glucose, all right? But previously, we only have the glucose detection, but now people are moving on the glucose monitoring system. So that's how the evolution. I will go into details towards later on the glucose sensor. Now, when we have a device that we want to fabricate and we would like to develop a biosensor, what are the criteria that we need? Of course, we need to make it advancement by merging with the nanotechnology, such as nanomaterials. So looking at this, to make the enhancement of the sensor, we immerse the nanomaterials, whereby you could see that we have a nanogold. Nowadays, people are working on nanogold, nanoparticles, and then nanowires, and all sort of nano have been trying to emerge with the biosensor, with the biomolecule, with the nanomaterials, and put it on the transducer. So what you may see, looking at the carbon allotropes, okay, started with fullerenes, it goes to carbon nanotubes, and now it goes to graphene. So what are the advantages of these materials? Actually, the surface area of that material could give a very high sensitivity when we develop one of the biosensor that we aiming for. And also the functionalizations of the carbon material, it could be easier for us to develop it. And modifications of the surface of this transducer is one main thing when we are trying to have a suitable environment for the biosensor. So this kind of materials, regardless whether you are using on carbon base or whether you are using organic base like zinc oxide, they have their own advantages for the biosensor specific. If you are, for example, if you are looking for HIV disease, you have to study which are the biocompatible material that works for it. And when you are doing on cervical cancer, you have to go on deeper, what are the suitable material for that particular disease. So for your information, in our institute, myself, I'm working on HIV disease, which determine the protein that presents on the virus by the early detections. We may know that HIV have several stages. When that person have the HIV virus, they will go to the AIDS at the end. But to make it their life longer, life longer, what we do is we trying to identify the proteins in the early stages, which is about 3 weeks. So when we can identify that protein, which is TAT protein, TAT, that person could be treated in early detections that could prolong their life to become AIDS. On the other hand, the cervical cancer, we did tests, we did like a questionnaire with a woman. Why the woman are very difficult to go for a checkup, for medical checkup, cervical cancer? The reason why is it's pain, because they need to take a tissue. And some people are fear. Okay, so we create the non-invasive method by studying the DNA from saliva. We tested it and we measured it in clinical, and we found it that the result is quite similar what we have tested by using the tissue in the hospital. So that's how we do, and when we identify it. And of course, when we want to identify the disease, we have to make sure the choices of the material is really compatible with that DNA. Otherwise, it's not going to work. Okay, otherwise it might be toxins, or it might be it could be even worse, and it could be even worse. So you have to identify what are those materials that are suitable for whatever disease that you decided. So a part of it, the nanomaterial and the nanostructure have been given a very high impact on the sensitivity of the biosensor. So in my case for HIV, we do on the graphene and we also did on the diamond. Most are the carbon-based material. Why? Because the carbon-based material is actually, it provides a very suitable environment and it's easily to be modified with the surface. When you want to do it attached with the DNA, or even though you want to see the behavior between the small molecules or the cell, it was so easy to be modified by using a carbon base. But in somehow, there are some people are using organic material, such as zinc oxide, titanium oxide. So it all depends what are the sensing mechanisms that you are looking for. Now, the surface functionalization. When I'm talking about a carbon-based material or nanoparticles or nanogoals, this functionalization is actually important as part of the biosensor. Okay, looking at this, we have a conjugate chemistry, we have a ligand exchange, we have a bioconjugate, we have a functional group transformations. These four functionalization has a different applications. Okay, for example, for the ligand actions, it's more suitable on the biosensing and bioimaging. But for functionalization group transformation is more towards chemophototherapy and drug delivery, and the bioconjugating is more on biosensing and drug gene delivery. This is what I say, when we are trying to develop a biosensor, we need to identify which are the suitable surface, which are suitable for the samples that we are going to identify. Now, the emerging of the functional materials. We know that in drug delivery, like for a cancer cell, nowadays, people come up with a new disease, like we never heard of the disease. It's been like weird disease has coming up, especially in Malaysia. Because we are in tropical country, there's a lot of new disease coming up. Maybe due to the climate changing, maybe due to the immigrants, because we have a lot of foreign workers in Malaysia. So it might be some of the reasons why we have a lot of disease, a new coming disease. So what we need to identify is, we need to have the emerging functional material, such as metal nanoparticle, to become a catalyst and therapeutic agents, and also as a drug delivery carrier. So these are an example like what we may have a look, the future medicines as part of a biosensor. As you may see that the magnetic core, the latinate dopant, the nanoshell, the polymer coating, the fluorophore, which is signal imaging, and the cell membrane penetration ligand, the therapeutic aging, and the targeting agent. Those are the functional materials that have been developed so far, that have been go through with the research in the biosensor. Okay, now, when we talk about the biosensor, the device, when we talk about the drug delivery, definitely we want it to become smaller and smaller, right? But towards the end, we would like to have like imprinted on the skin, like wearable technology and so on. So the drivers of biosensor miniaturization is actually they have a complex of the things. It have a microfluidics, okay? It is the combinations of the biomems, the microfluidics, which is lab on chip, and the microtas. This kind of drivers actually could be expand, could be changed, could be performing into a biosensor. So the most common, the recent one is a lab on chip, where is a concern with miniaturization is much more smaller, with the integrations of laboratory process and experiment into single chip. But is not only lab on chip. The lab on chip can be integrated with the portable devices as well. So this is what the drivers. When we develop a biosensor, we definitely want it to become a smaller and smaller due to the cost. And of course, the sensitivity of the biosensor need to be accounted as well. So that's why in future, I mean, even now, we could see some of the biosensors that have been in the market, it's very small. Okay, so the emergence of the nanomaterials and nanostructure is actually the biosensor, it's part of the biosensor. Okay, now the evolutions and the challenges in the biosensor. I have picked up 4 topics on this evolution. The first is the glucose biosensor, the bioweapon, infectious disease, and the wearable technology. Looking at this, the demand of the glucose biosensor, look at the figure in China, in India. I think I've seen Czech, Republic of Czech, but in the small, only a small numbers, okay? We do have in Malaysia, Malaysia is about 2 million. It's about 1% of the population in Malaysia has a diabetes, which is quite high, I would say. It's really high for us. So, looking at this, the demanding of the glucose biosensor have tremendously. Even they have so many devices, so many techniques, so many technology have in the market. We have been established for the glucose biosensor, but still there are a lot of companies trying to optimize, trying to get a better sensitive for the glucose biosensor. And looking at this, the evolution of the technology, in 1917 is the first generation is more on reflectance emitter. The second is towards on smaller blood volume, less pain, shorter test time, better accurate and miniaturization. They're trying to make it smaller. But the third one, it has becoming on the continuous monitoring glucose, and then the invasive and minimally invasive. But now, people are looking for the non-invasive monitoring, which is, I believe, sweat is the most common thing, the sweat, and also the saliva. When we say about the sweat, the wearable technology is one of the advanced for the biosensor that people are monitoring their glucose level in the blood. This is what the technology on the glucose. Why? Because these are the matters, the cost effective, the comfort and the convenience of the people. Okay, so the evolution is like the portability and the continuous monitoring with it's much more becoming a wide market for the glucose biosensor. When we look at this, we see this is for 2010, even more now. There's a numbers of companies are doing on continuous monitoring with a non-invasive method by using urine and saliva. So this is some of the glucose detection mechanisms that are really being commercially and the common people are working on it. So you can see that they're using the enzymatic, okay, the enzyme that looking at the degradations of enzyme, the temperature, the humidity, and also the oxygen dependent. And they use the expensive noble metal catalyst, which is like platinum, gold, and it also show you a slow reaction kinetic of glucose oxidation reactions and the non-enzymatic glucose detections by looking the hydroxyl groups, the reductions of the hydroxyl. So this kind of biosensor is actually what they are doing currently, but the challenging is that the high performance catalyst at low cost, the limited of hydroxyl formation in neutral conditions, and reducing selectivity. So when we do in a non-enzymatic glucose sensor, the challenge is the reductions of the OH is a very low concentration, that is challenging for the researcher to identify it. Okay, and of course, the reduce in selectivity, when it comes on the non-enzymatic, they still have a limitations on the selectivity, which is when we use the mediator have not been appropriately attached with the glucose sensor and measuring towards in a lower concentrations. Now, on the weapon, from the glucose biosensor, now we move on to weapon, the evolutions of weapon. We might know that the biological warfare is like, it has been extensively used probably in the past few centuries. Okay, so they might use a certain microorganisms, toxins like a microbial plant or animals to produce disease and death among humans. Okay, with the livestock and the crops and so on. And also the bioterrorism is one of the use of microorganisms as well, or product of microorganisms to generate fear, morbidity and mortality among our populations. So what we sense in the weapon is these are what we are concerned that we could categorize whether it's high risk agent that easily disseminate and result in high mortality, and the second one is the highest priority agent that moderately easy to disseminate, and the emerging pathogens which could be engineered for disseminations and potential for high morbidity. I believe that a bioweapon, there's a lot of meanings in a bioweapon when we talk about bioweapon, but looking at this case like influenza, the bird flu, it could be one of the bioweapon that happens, around the world in global. Okay, when looking at the history of this, from 2003, they have the first published account of probably secondary human transmission of avian influenza, and moving towards 2011, and we could see the increasing of the death due to the influenza bird flu have been occurred. So, in 2011, they have a biosecurity official issues on this influenza. Okay, it's a part of pandemics for humans when it comes on influenza. So it could be lots of measures, also lots of influence due to influenza. On the other hand, so these evolutions of the influenza could be one part of spread it. Is it they are purposely doing that or impurposely? So we have no idea. But the thing is, all of this has the strategy of how does it could be. So by having as a bioweapon, we need a technology as a biosensor that could detect the determinations of the influenza. Whether, in the international airport, some of the airport, when we screening, they could see the temperature of our body and what are like imaging, whether you are bringing some of disease something. There are some of it are using it, but not in Malaysia yet. So these things of like from foreigner worker, they came to Malaysia, some are illegally, okay, some are legal. So it depends how does the human being they came with. It could be as a weapon, but we might not know on this case. So the barriers to the bioweapon is actually using a living organism. It's sensitive to environment and handling conditions. And of course, it behaves unpredictably. We can't predict what would happen. So that's why we need advanced technology for a biosensor. But how to determine the influenza? How to identify in the early stages? How do we imagine the person whether they bring a disease or not? And how we look on the plants and the animals and the foods that we eat, whether it have a pathogens, whether it have a something that could demolish or could demolish our our body? That's the questions. That's why we need a biosensor. And of course, when we talk about the bioweapons, is it detect to treat, or is it detect to protect? So we need to identify when we develop a biosensor for our bioweapons. So the solution to this problem is actually to employ the molecular techniques which can identify the chemical markers from known biological agents. That's why we need to find a suitable biomarker. That's the most important. If you can't identify the biomarker, for example, for influenza, we can't even detect the influenza. We can't even prevent the influenza if we couldn't find a biomarker. Now, for the food industry as well, it could be one of the agro-defense as a pathogens in the food. Okay, we grow the foods, we grow the plants, but we might not know the pathogens what have been in there, and the soil, and also the chemical stock that we use to make it grow, to make it much more bigger and bigger. It could be some of the toxics for human. It depends on what we are doing. That's why with this kind of biosensor, we need the platforms of the biosensor to identify that whatever that we eat, the foods, it could be good, better for the human. It's not like toxics for human. It could not affect human, but it's giving a good balance for the human. That's why the food industry are becoming demanding. As you may know, Malaysia is a tropical country, so we have a lot of farmers, and in fact, the aquaculture, the plants, and there have been so many things have been growth, but again, there are so many, we have so many insects and so many like a small that could be poisons all the plants. So we need those kind of things. We need to monitoring the temperature, the humidity, and etc. to make sure that the plant is grown in a good. But of course, the technology of the biosensor is needed on this particular view. And we also have problems on the rice. Our rice is like small and long, okay, our rice. So when the paddy it start to harvest, but somehow the fungi have been demolished the rice. So how do we define that? We need to study the fungi. We make a biosensor to identify once the paddy field has been infected, then we could prevent the paddy field to become growth in a good way. That's how we did on the food agriculture. Now, for the infectious disease are caused by pathogenic microorganisms, such as it could be bacteria, virus, parasites, or fungi, as I mentioned previously. So the disease can be spread directly or indirectly from one person to another. In Malaysia, we have a mosquito, we have dengue, we have chikungunya, there are several types of dengue that we have in Malaysia, for your information. And even though we need to prevent that, even though we have developed a biosensor for dengue, but it's not only for the whole people. The dengue has several types of the dengue disease. So each person might be getting bite from the mosquito that from the beginning, maybe it came from the elephants and goes to the human. On the other hand, the other person probably come from the cow and come to the human. So they're bringing a different DNA, definitely. So that is the issue that happens in Malaysia. And also, the HIV, I think we are aware how does the HIV infected, and also the Ebola, the outbreak of recently with the Ebola virus. So, looking at the Malaysian scenario, okay, we have been increasing a number of that in dengue due to the mosquito. And looking at the state, the Selangor is the greater value of the Kuala Lumpur, which is our city center, okay, in Malaysia. It has been increasing in the death of the leptospirosis and also the dengue. Leptospirosis actually came from rat. We have a lot of we have a lot like, oh my God, like hills, and we go for picnics, and people somehow would not clean it properly. So the rats comes in, eat it, and they pee into the water, and the water have been polluted with the rats' pee. And when we will go there for like swimming or something, so it will get effect to us, and it has been increasing at one time in Malaysia. Is really bad on the leptospirosis. So what we did, we need to identify the water, whether this river is actually have a danger for the human towards the leptospirosis, or it's safe for people for picnic. So at one time, we have been abandoned all the picnic areas because we want to check, to measure the quality of the water. That's what we are facing in our country. And also, the typhoid alert, it actually came from Salmonella E. coli. We have a raining seasons in a year. In a year, we have like 3 months to 4 months. It's terribly bad, and it has a lot of flood everywhere. So when we have a flood, this disease came up, okay, like E. coli, and we have shortage of the water and with the rural area and etc. So we need to identify whether this water could be safe to be drink with a rural area person when we have this kind of flood. Okay, so that's why Malaysians have developed, put an effort to work on the biosensor, and that's the evolutions why we need a biosensor is part to help to solving the global health, especially in Malaysia. I'm sure the dengue is not only beginning in Malaysia. It has turned out to be in Japan as well recently. So the Japan have made a tremendously effect on researching of that particular dengue as part of it. So this, how Japan get the dengue? Perhaps during the visiting, like the visitor and travelings, and some of it, the climate changing, the mosquito came over. So there's a lot of clue and issues that have come up with this dengue, especially in Malaysia. So the emergence of the infectious disease is actually, it depends a lot of things. It could be the environmental change and land use. It could be a demographic and behavior, the changes, and the technologies and industry changes, international travels and commerce, microbial adaptations, and breakdown of public health measures. That's why the emergence of infectious disease actually came from this kind of things, that increase in hospitality, new disease, increase in disease transmissions. So, sensor, the wearable technology. We have 5 senses. We have sight, hearing, taste, smell, touch. So what are those things as a part of biosensor? You may have a look, like we have a smartphone nowadays that could be one of the photo transistor, image sensor, and also gas sensor. So those kind of things could be equivalent with the biosensor. Now, the wearable technology, if you know that it is a wearable device or body bond that computers that we worn by user. So it's actually interact with wearer without manipulating. It always on, which is always working, and it performing a calculations and process informations. So the drivers of wearable technology is, of course, it need to be faster, smaller, and cheaper hardware. And the cloud storage is needed, and the locations of the data. So these are the wearable technology. So how does we combine we emerging with the bio? This is where we come, that the biosensor convert the biological element into the signal output, and they create a biosensing, a wearable, such as the head, okay, like the spectacles, and then the back, the waist, and the arms, the body, the wrists, and the legs, like the shoes. So those kind of invention is actually using the biosensor for this wearable technology. Okay, so the inventions have been so far like the heart rate sensor, the fitness socks with the full band, and then the continuous glucose monitoring, and also the sleepy sensor. What are they using? How does they detect the biological sensing thing by using the wearable? Is it heart rate? It could be heart rate, it could be your sweat, okay, your blood circulations, the manipulating and the magnetic. Okay, so those are the technology that they use for this wearable technologies. Those are invention. And digital health nowadays has been growing from 1970 and up to now. We have a very wireless sensors and so on and device. So as a result, these are what we aim to reduce the mortality and the disease. And it's not only for the glucose monitoring, somehow the wearable technology could be one part of monitoring on the whole body of ourselves. Like if you ever look on the video of the Samsung technology, they have shown you how when we wake up early in the morning, we'll be in the mirror has screening us and giving us what is your temperature, how is your blood rate, how is your heart rate, your blood circulation. Those kind are the advanced technology that we are looking for a digital health. Okay, but again, the lacking of the chemical sensor we are still lacking of that. The challengings of this, the wearable chemical sensor, is actually the continuous exposure to the fluid to wear and tear, and the frequent recalibrations to correct for a signal drift over time, and the smart materials for protective and active layer, because we need to identify what are those materials that are capable towards the protective, okay? And also the minimally invasive device. There are very few, and these are still lacking. Those are the challenging that I could see that we could come up with the solutions of this to overcome all the limitations of the wearable, especially in the chemical sensor. And these are ones of the requirements that for the wearable sensor, which are idealized cases. We need to have the consumer behavior change and early diagnosis and interventions. Okay, and of course, for the medical practitioner is they want to remote patient monitoring. They need to monitor the patients and to support for telemedicine service. For the performance requirement, of course, in whatever biosensor, they need a very good quality performance. As in a wearable sensor, the functionality, the meaningful of physiological data is actually actionable to the end user, and convenience. It should be convenience when we're using the wearable sensor. So, this is one part of an example on the cardiac disease, the past, present and future. When we look on the past, they are normally using a microscopy, the Western blot, the spectral photometry and enzyme assay. But present, there's a lot of number of commercial devices that have been commercialized for the cardiac disease, cardiac vascular. So, and also part of it, the field effect transistor and the nanomaterial is part of the emerging for the future technologies that what we have been doing so far, even now, up to now. But what we are looking on the future, we have seen the future, but it might be, could be in the more digital. It's only they collect, they transmit, and they receive the data, and they're reporting to the medical practitioners. This is how the future is going to be for the future technologies, especially in the biosensor. I believe that one day we only could we put it plug or something on our body and they collect the data, they receive, and they could be advise us what is your health condition and so on. It could be one of the future technologies in one day. I think I'll come to the end of my talk on the evolutions of biosensor. As a summary, I would say that the biosensor, it could be comprising with two broad categories. It should be sophisticated, high throughput laboratory machines with the rapid analysis, the accurate and convenient measurements, and also easy to use portable devices for use by non-specialists for decentralized and in situ or home analysis. But the challenging is the biomarker. We need to find the suitable biomarker, the tedious preparations, and then the stability of the device to protective the layer of the transistors, and the sensitivity. How does the device could be prolong the sensitivity, whether it could be reproducibility, reusability means we're not only using one time, but we want to use so many times. So those kind of things that we need to take into account when it comes on the biosensor. I think that's all from me that I would like to share with you. Thank you for your attentions, and yeah, that's all. Thank you.